Okay, let us now see this. Now we are going to see the vector method and then the geometrical approach. But when you are given a question, you need to use only one method. So in the next lessons, so I'm going to be just using using one method. Okay, so here let me hand both, then the next I will use one. You are going to see which one is easier. Okay, a man is traveling at 30 meters per second due south. Due south means it's continuing in that direction. So if this is our man, so this is the compass. Due south, this is north, then this south is in that direction. So at 30 meters per second. So to get the velocity now of a man in the vector form, it's going to be now due north, meaning the x component is 0. So you have 0, but since going in the north, you see it's going in the north, but that would be in the negative. It's going in the south, so but in the negative direction. So this would be negative 30. If it was going up, then that would be a positive 30. So this one shows it's going in the negative. So that's the velocity of the man. And wind appears to be, whenever you hear the word appears, that means that wind relative to man. So they are giving us now here that the wind relative to the man is in 60 meters per second in the direction of southwest, in the direction, so it's going in the southwest. So we draw our compass like that, southwest. Now whenever they hear the word southwest, they are giving you, in simple terms, southwest is always 45 degrees. So it's going in that direction there. So you are free to put your 45 here or here. I'm interested in putting it here, 40 degrees. So that is how it's going to be. So this velocity is 60 meters per second. So to resolve this, we shall move down, then we shall move in this direction like this until we meet that force. So you see this angle, so this is its adjustment. So this is going to be 60 cos 45, cos equals with adjustment, and so this one is opposite. So this will be 60 sine 45 degrees. So now our V, wind relative to the man, is going to be our x component. You see it's going in the negative, the x component or the horizontal component. So it's going to be negative 60 sine 45. Then this one is also going in the negative. This one in the vertical component. So negative 60 cos 45 degrees. So after getting this and then this, we know that our velocity of the wind relative to the velocity of the man is equal to v of the wind minus velocity of the man. From here you can start. When I take this side, and so now my velocity relative to man plus velocity of the man is equal to velocity of the wind. So sums it there. You can see I'm going to be having now, this one is negative 60 sine 45, then negative 60 cos 45 plus that of the man, 0 negative 30 to give us velocity of the wind. Now this is what we call the true velocity of the wind. From there, after simplifying, our velocity of the wind is going to be, you are free to use your calculator. So you add this plus this to get the horizontal component, then we add this and this to get the vertical component, the overall. So from there, we get negative 60 sine 45 plus 0. This would be negative 42.4264. Then this one will combine that and that. Cos minus that. This will give us negative 72 0.4264. Of course, you know, sine of 45 is the same as cos of 45. So these are in meters per second. So if we have it now, we need to get its magnitude. So, or you can simply sketch it here. You see it's in the negative and then also in the negative. So this is what we are going to be with. See, it's in the negative. So this is our B of the wind. The X is 42.4264. Then also this one is where it's going down. 72.4264. Now is that we always want our angle to be there. So from here, you can see that our velocity of the wind is going to be the square root of negative 42.4264, the whole square, then plus negative 72.4264, the whole square. So our velocity of the wind there is going to be it's 83.9379, which would be giving us 93.8 meters per second. And now, with its velocity, it is also direction. So from there, we can come and get our alpha, which would be tan inverse of the opposite. You see to this angle, the opposite is this, 42.4264 over the adjacent. Our adjacent is this, which is 72.4264. And so our alpha there will be here I'm getting 30.36 degrees. So now I can ever describe this. So therefore, velocity of wind is 83.938 meters per second in the direction of, now this one you see, we are going to say south, you see it's going this side, but 30.6 degrees towards the west, as simple as that. South, 30.36 degrees towards the west. Or you can get this, and then you get from the north line, then you get this hand. So you get 180 plus this, and then you give, no, you can say in the bearing of 180 plus alpha. So it's up to you. So that's the vector approach. Let us come to the geometrical approach. Now the geometrical approach, we first draw a compass combining this and this. So see, if I draw that compass, I'll be having something like this. So that's my compass. I have this one, is going to be 60 meters per second. This one is going to be 45 degrees. And then this one is going to be our velocity of the man, which is 30 meters per second. Now, see the direction this one is moving. So we need to get our result, and remember, the relative velocity is always this one is going to be our result. So now it means that I can draw this side, then anyway. So if you have this, you can extrapolate it, and then it will be coming this side, then it will be coming this side. But remember, always the relative velocity is our resultant. Let me show you here. Okay, so we need a beta space. So let me add some space here. Okay, so if we have sketched that, we have to put, first of all, we put the two forces onto one thing. So we put our relative is going in this direction, like this. Then remember, if we have this our v of the man, which is 30 meters per second in this direction, this is our direction of the relative velocity, which is 60 meters per second. Remember, we always get the negative, so we get the negative of this, so meaning we have to move in the opposite direction, so this will be our negative of the man. So the negative of the man, where, and then this one will be, remember this is our mu m velocity, no, this is the velocity of the wind relative to that of the man. Velocity of the wind relative to that of the man. So what we do, where we stop, because we have to always add the velocity of that man, then plus the velocity of the wind. So if this is the man, then we shall come into this direction. Where this one stops, we shall get our v there. So assuming he's stopping there, then we shall come and get, this will be our velocity. So that's going to be our velocity. See the direction, like this, then like this. So this will be the velocity of the wind, which we are looking for. But not this. Remember, this was 45 degrees from here. It means that now, if that is 45, the balance from here, because this is a straight line, it will be 135 degrees. Okay, remember we have this, and we have this. This one is just showing the direction. So we have this, and then this, so we can get that. So how are you going to use? Using cosine rule. Using cosine rule. Cosine rule, we shall get our v, w squared, equaling to 60 squared plus 30 squared minus 2 of 30, then 60, then cos of 135 degrees. And so there our v, w is going to be, you press that onto the calculator. It's going to be 83.938 meters per second. So that's going to be our velocity of the wind. So always, know that we have to go opposite like this, then like that. So this side is just saying that we are changing the direction of this, but the magnitude of this velocity is not changing. So this velocity here is just the magnitude, but we are not changing. Because in the relative velocity, we have to put the negative of 1, then we add on the positive of 1 in that direction. Okay, so now if we want our angle, now we need this angle here, alpha. Need that angle, alpha. So we have this, we have this, we have this, and then this. So there, we can use the sine rule. So our sine rule, we have now this is opposite to this, so we have 60 over sine alpha equaling 2. Now we have this and that. So our VW, which is 83.938 over sine of 135. And from there, our alpha is going to be, you get this time, this then divided by that. So here, my alpha is where is our, it's opposite to this, and then this is opposite to that. So 60 sine 135 this times this, then we shall divide this after. Divide by 83.938. Then shift answer. So I'm getting 30.36 degrees. I think you can see it's the angle we got. Then you can describe using that idea. I think we start this one is shorter. And always the geometric approach is going to be shorter than the vector approach. Anyway, that's it. I wish you well. I think this note can help you here.